So I'm here to talk about enterprise challenges of test data. So if you are testing something simple, then this presentation might not make a lot of sense to you. You might be thinking, what's the problem? But if you're testing large enterprise scale applications, systems of systems, then you are probably struggling with a lot of the problems that I'm going to talk about. The fact that there are many, many applications that have to coexist, and these applications can be large, complex, interconnected, sharing data in ways that maybe not everybody understands. What I'm going to try to do here in the next 40 minutes or so, leaving time for some questions, 45 minutes, is to point out some of those challenges so that you can identify them in your own organization, your own testing, and better address them. I am happy to take questions at any time, by the way, especially if I do manage to use some complicated English word that you don't understand, that I confuse you with that. Okay, so if you just stick your hand up and ask me to explain, I'll be happy to do that, okay? So, test data. We can create it by hand, actually manually enter data into tables, right? You're laughing, but it happens. Sometimes. Or we can use a tool. Now this can be a custom tool that generates data according to specification, or it can be a tool like, say, Excel, where you're using random number generator features and copy and pasting records and so forth, which is a little more cumbersome than a custom tool, but then again, everybody has Excel. So that's one option. Another option is just use the real data, actual production data, right? We can take all of it. We can take some of it. We could anonymize it before we use it, or we could pseudo-anonymize it before we use it. And if you're thinking, what does he mean by that? I'll explain. So, chances are good that you're going to need to do many, if not all of these things in the creation of data. Some mix. If you just rely on one, it's probably not good enough. And you're probably going to need tools if you're working at an enterprise level. Again, if you're testing something very simple, I hate to chase you out of my own presentation, but you're probably in the wrong room. Okay? And so if you're wondering, well, what does he mean by simple? I'm going to show you on the next slide. So to define what I mean by simple versus complex. Now, regardless, simple, complex, something to keep in mind. If you have production data and you want to test on actual production data, and you're going to be hip and cool in testing in production, better think about that, because that could change the data, right? Or alternatively, somehow or another, data gets copied into the production environment. You might say, oh, that never happens. Yes, it does. I'll give you an example. About 10, 15 years ago, a utility company in the UK, Britain? Yeah? Okay. They didn't know if that was a common abbreviation here. They were testing a mass mailing that was going to get sent out to all their customers. I don't remember what it was for, maybe to introduce a new bill format or something. So they tested the mass mailing, and somehow or another the mass mailing data got into the production environment, and the mass mailing test letter got sent out to all of their customers. The test letter started off, salutation, dear idiot. Okay. So the person opens it, dear idiot. Now, I've heard worse stories than that about test data that gets into production. So simple, complicated, whatever you do, be careful about doing anything to production data or allowing your test data to leak into production, because very unpleasant things can happen. Okay, so simple. What do I mean by simple? Let's say that you're testing a very simple mobile app, something that looks kind of like that. You got a data repository in the server side, firewall, web server kind of thing, cloud app running on the phone. Okay, and doesn't really deal with a whole lot of data. Maybe there's five or six tables in a simple relational database. Maybe you had a gigabyte or less, and it's all in one database management system. All the self-contained, good relational database practices followed in creating the database. Simple. Okay. You first get started testing something like that. Maybe it's small enough that, the data set is small enough that you can just generate your own data. Half an hour, you can create the data and boom, and populate it in there. Yeah. Or there's no personal identifying information in the production data, so you just use that because nobody cares. It's fine. Management says, yeah, whatever. So if that's simple, if that's what you're dealing with, something simple like that, then the kind of problems that I'm about to talk about are just going to go right over your head. You'd be like, no, I'd never have that problem. Well, yeah, because this is a very simple world. Okay? Now, the thing is that you might not have the problem now, but you could have it later. Okay? Because things change. Capabilities are expanded and so forth. So that what I'm going to talk about now might not be relevant to you today, but it could be, in a year or two when your company has been acquired by this other big behemoth out there, and now there's all of this other data that you need to interact with. All of a sudden you go, oh yeah, that's what Rex was talking about, that stuff. Because enterprise world looks more like this. So you've got satellite offices. You see a satellite office over there on the left side. You got the data center there on the right side, and there's a lot of stuff in that data center. Notice there's not just one database, there's N databases, multiple databases. There's a mainframe in there. Some of the databases are not relational, so you got some Hadoop or something like that floating around in there. And you've got back office stuff, you got Wi-Fi stuff going on there, you got internet, you've got stuff out in the real world, you got mobile apps that are interacting. And if you're running a bank or an insurance company, something of similar scale, I mean, this is what your world looks like, except that this is actually just a gross simplification of it. It's usually a lot more complicated than that, right? But that's, a simplified version. And now, you think, oh, yeah, okay, test data. Woof. Any one system, fine, right? But system integration testing how all of that stuff interacts, this is where it gets hairy. This is where it gets really complicated. Now, some people just kind of throw up their hands and go, oh, can't deal with it. Well, you can do that. Not a good idea, Definitely a better idea to think about how am I going to test interoperability through the system of systems, right? So, excuse me. So you were laughing earlier when I made the comment about hand-generated test data. Oh, you kind of were a little bit, right? And because you might live in that kind of world, and you're like, how did I get to hand-generate test data? because, you know, and think about that diagram I just showed you, hand-generate test data. We're talking about terabytes of data, you know, some of which goes back 20, 30, 40 years. Hand-generate? I mean, no, that's just delusional to think that you're going to be able to do that. So you could say, well, okay, I'll get data generation tools. Okay, yeah, the data generation tools can create tremendously large amounts of data once you figure out how to use them. And so they're a little harder than they might seem, but they can generate a lot of data. But one of the problems is does that data, the generated data, look like production data? Because it needs to. Because the test conditions that are being covered by the testing are only being covered by the testing if the test data is correct. Right? What you think you're testing and what you're actually testing is not the same thing if the data that you're using for testing is not the same as the production data, which can lead to some very unpleasant discoveries in production. And unpleasant discoveries are bad, right? Think dear idiot, right? That was an unpleasant discovery. So this is the nice thing about production data, because it's like one less thing to worry about. Does my test data look like my production data? Am I actually testing what I think I'm testing? Well, if I'm using production data to do the testing, well, of course it does, right? At least it looks like what the data looks like now. Of course, if you're adding new features and capabilities, that's something you got to keep in mind of, well, I'm going to have to add some new data to take into account the new features and capabilities being added. But at least the existing stuff that you're testing with production data, okay? You are testing exactly the kind of data that your apps are going to be looking at when they hit production. So that's good, yeah? But there are issues. And usually, one of the biggest issues here is this one. Notice the title there, Fly Meets Ointment. That's, I think, appropriate for the Heisenbug conference, right? You guys familiar with this expression, fly in the ointment? The thing that goes wrong that screws everything up? Yeah, well, so the thing that goes wrong that screws everything up with production data for testing purposes usually is personal information, personal identifying information. You guys have laws like that here in Russia about people's personal identifying information and the uses to which it can be put and who's allowed to get a hold of it and so forth? Yeah, and it's very inconvenient because those laws are different around the world. So if you're working on enterprise scale data, it's usually a safe bet that that's data that's used by companies that have offices in multiple places around the world. So, oh crap, now I've got to think about all of these different laws in all of these different places, right? So the whole idea of trying to secure the way the data is being handled in all of these different locations in such a way that it is conformant with local legal restrictions is usually just a huge nightmare. All right, so you're not going to be able to test with the actual honest-to-God production data. You'll have to do something to it called anonymization or scrambling. You basically change it in such a way that the data looks real, but personal identifying elements of it have been removed. Okay, but now that sounds great, right? And like, you know, it's like, oh, look, it's a magic wand. Hit the data with a magic wand, and now it's fixed. It's familiar with the phrase magic wand, right? Yeah. Okay. Yeah, except that it's not. There aren't any magic wands. You notice this? You get into doing something for a while, and then it's like, whoa, that sounds like magic. So therefore, it doesn't really work that way, right? Because there isn't any magic. So you have to be careful, because if you use the thing wrong, use the anonymization tool wrong, then you haven't actually anonymized the data. It's really easy to de-anonymize the data. Also, if you use the tool wrong, the meaning and meaningfulness of the data from a testing point of view gets corroded, gets undermined. So you might be thinking, well, what is he talking about? Meaning and meaningfulness. So, a really simple example. I need to change people's names in a database so that there are no real names in the database. Okay? So I change John Brown in one record. John Brown becomes Lester Camden. Okay? Now, those names may sound strange to you, but they're both actually fairly typical American names. You would not be shocked to meet Lester Camden. Okay? But it would be bad if my tool changed John Brown to Charlotte Dostoevsky. Not that there's nothing wrong with Dostoevsky and there's nothing wrong with Charlotte. I have a daughter named Charlotte. Okay, it's a great name. But it's not so cool when John Brown becomes Charlotte Dostoevsky. Well, it's cool if John wants to become Charlotte. That's okay. I got no problem with that. I mean, you know, you see the problem here, right? Because now if there is a field in the database somewhere that has gender, gender Charlotte Dostoevsky, gender male. Okay. See what I mean? So it has changed the meaningfulness of the data. Now, there can be perfectly good reasons why you would want to have the gender field be wrong in test data. Okay, that's an interesting test. What happens if the gender field is reversed from what you would expect? It's an interesting test, but you want to do that on purpose. Okay? You do not want the tool just sort of randomly introducing errors into your test data because you're going to have a lot of problems with that if it occurs, right? The interpretation of your test results is going to be problematic. So basically, not only do you want to be careful that the anonymization process preserves meaning and meaningfulness at the individual data field level in each record, but also across records joined together. So if you do any sort of query or view or join across multiple tables in anonymized data, you need to get the same information as you would using those same queries, views, and joins on production data. Right? So if I do a query for looking for transactions associated with Lester Camden in the anonymized data, and I do a query looking for transactions associated with John Brown in the production data, I better get the same number of records in each one of those, right? If it's a different number of records, there's clearly something seriously wrong. And even if it's the same number of records, there could still be something seriously wrong if semantically the information in those records is inconsistent. So, for example, if the total number of sales for sales to Lester Camden is 1,000,000 rubles, then for John Brown, it better also be 1,000,000 rubles. See what I mean? So you've got to be really careful that this anonymization doesn't screw things up, because otherwise you're going to have issues when you do functional tests, but also non-functional tests like performance and reliability and load. See why? Because like if the number of records that are returned by a query is 2 orders of magnitude less on the anonymized data than it is on the actual production data, am I actually putting the same amount of load on the system when I'm running test queries against it? Nope, I'm not, but it looks like I am, right? Which is always really bad in testing, right? Where you think you're covering something, but you're actually not. Because now what you do when you report your test results is you're giving people false confidence. False confidence is not cool. So you do tell, oh, yeah, we tested that, it works just fine. And then you go into production and people are going, what the hell? Why are we hearing about 15-second response times? Didn't you load test? Oh, yeah. Well, yeah, but the data, when it was anonymized, got screwed up in such a way that it actually reduced the amount of load you were putting on the system, but you didn't know it. So when you go through this process, you got to be really careful. This anonymization process. And is this anonymized data really a good reflection of the production data, while at the same time being indeed compliant with laws wherever it's going to be with respect to removal of personal identifying information. Now, it gets worse. It gets more challenging because a lot of times when you're dealing with enterprise scale systems of systems, you're not just talking about one database, one repository. You're talking about multiple repositories, multiple bases out there. Now, I can use, if you're familiar with relational databases, I can use relational integrity rules in the way that I set up my database to prevent certain kinds of problems, right, within that database. But how about across 10 or 15 different databases? Nope, not going to be able to do that. You might say, well, yeah, but they're different databases. Well, yes, different databases, but they might have related data in them, and you might want to be able to do testing that pulls across multiple databases and looks at those relationships in the data. So, example here, let's say I've got 3 applications, like a insurance application, well, let's say life insurance application, banking application, and car insurance application. Okay? And it's all in the same data center, and there are overlapping customer sets. So some of the people that have bank accounts also have life insurance and car insurance. And I want to test some ability to, say, transfer information across those systems. Okay. So what happens when I go and anonymize the data? Could be a problem, couldn't it? Because the anonymization could be fine in each of the databases, but if John Brown becomes Lester Camden in one database and John Brown becomes Bobby McGee in another database, now when I try to test across those, looking for, show me all instances of John Brown in any of these 3 databases, right? Broke. Because if I search for Lester Camden, I only get Lester Camden in one place, right? Because John Brown got turned into Bobby McGee in this other repository. You all following what I'm saying there? So now I've broken a relationship that spans databases. And so I'm going to try to do end-to-end testing of queries like that across these multiple databases, looking at things like, we'll say, data analytics, business intelligence type of stuff. Now it's broke, right? But it doesn't necessarily look broke. Looks just fine, system by system. So again, here, if you've got these kinds of systems that have these interrelated data repositories, when you go to do the anonymization, you're going to have to figure out, can I force it to anonymize the same way on each of these repositories, so that when I go and do these kinds of tests, I don't have effectively broken linkage. Okay, you guys following this? Yeah. I know it's late in the day, so I want to make sure I don't suddenly start confusing you. Okay, so that was kind of a drill down into anonymization and some of the issues there, especially in systems of systems. Kind of come back to the general question of, things that we have to think about when we're thinking about test data. What's the quality of the existing production data? Now, if you're sitting there going quality data, what do you mean? Well, data quality is an issue. And in production data, it's usually pretty bad. Believe it or not. I've heard estimates from studies that are as high as about 25% of records having some sort of error in them. So this goes back to Charlotte Dostoevsky as a man, right? That kind of thing. 25%. So it's pretty significant. So again, your apps are going to be dealing with dirty data, most likely, especially if it's been around a long time. Data that has a lot of errors in it. So you got to make sure when you're creating your test data that you're properly mimicking that. But if you're anonymizing production data, be careful here, because you have to be sure that whatever you do to maintain the error rates in your test data does not open you up to reverse engineering. In other words, pulling personal identifying information out of the test data by patterns that have been preserved from the production data if you use that. I'm sitting there thinking, oh man, he just keeps making it worse and worse. But you got to think of these things in advance, right? Because otherwise, again, it's bad surprises. Maintainability. You got to think about maintainability of your test data up front. I had a client tell me that they had this process that anonymized their test data, and I asked them, well, okay, how's that work? Oh, it's perfect. It's great. I said, well, how often do you do data refresh, the production data? They said, 18 months, 24 months. I said, God, why so long? Said, well, it takes about 2 weeks, the anonymization process to run, because of all the production data we have. And I said, you're doing it from scratch? He said, oh yeah, it's from scratch each time. I said, you can't go back and do some sort of like delta and look at what changed since the last? No, tool doesn't do that. Dope. Right? Stuff you wish you had thought of, right? But notice that initially that wasn't, with the first time when they were first designing a solution to the problem of how do we anonymize the production data, there wasn't any existing anonymized data to deal with, so that wasn't part of their thought process, right? We have an expression for this in English. I don't know if it translates. Painting yourself into a corner. Yeah? You guys have that in Russian? You're painting a floor, and you're painting the floor, and you're painting the floor, and all of a sudden you're like, oh crap, I'm in the corner, right? The door's over there. Yeah? If you're smart, you paint so that you back up towards the door, right? But you don't always think of that until you realize you're in the corner, and that's what these guys had done, okay? So, efficiency is important, not just in the initial acquisition, but also in the ongoing maintenance. Otherwise, you might find that you've painted yourself into a corner, and it can be expensive and difficult to get out of that. Now, another thing that you want to think of here is this issue of quiescence. And data quiescence. What do I mean by data quiescence? It sounds kind of strange. It's like quiet data. But if you're familiar with database terminology, basically data quiescence means it's not changing while you're copying it. Okay? And that can be a problem when you're copying the data to anonymize it. So for example, let's say that I have a consistency requirement in terms of the customer table and the sales table, okay, in my app. And there's supposed to, every time there's a sale, it's supposed to correspond to a customer. Well, what happens if the sales information and the customer information is changing while I'm doing the copy? See what I mean? I could get a situation where there's a broken referential integrity rule between the sales and the customer. Okay, so don't forget about that, because that could go wrong. And then when you go to do your bulk load of the anonymized data, your database comes back and barfs and says, nope, sorry, you busted my referential integrity constraint here. And the database isn't going to give you helpful hints. Maybe this happened when you were anonymizing the production data, and maybe you forgot to keep the data quiescent. No, it's just going to go, can't load record, referential integrity constraint. You get to figure that out. I can promise you, you won't be happy when that happens. All right, money. Money is always an issue, right? Is any of you out there, money is never an issue? No, okay. If you are and money is never an issue, I want you for a client. Please hire me. No, money's always an issue because you're going to need to have, the test data has to live somewhere, right? It has to have a home. So, database management system, server, disk space, maintenance costs, backups, backup media. Now you might say, we're going to use open source database management system. Okay, there you go. You can cross off the first of those bullets. Still got the other ones. We're going to put it all in the cloud. You guys got free cloud services here in Russia? There's no such thing as a free lunch, right? So either you're buying it or you're renting it, but either way you're paying for it. Yeah? Now, an idea here that might help you out, and I mention this just because I don't see a lot of it or hear a lot of it, is virtualization. Andre, you mentioned you wanted some animation in my slides, so they get an animated ghost for you there. So, storage virtualization. This could help, perhaps, in terms of some of the costs, and can allow for some sharing of hardware and resources. So this is something to look at. It doesn't solve a whole bunch of problems, but it could potentially solve a problem for you with respect to the costs that I was just talking about. And it's definitely underutilized by different testing groups because I don't hear anywhere near as much about this from people as I probably ought to. Any of you using storage virtualization right now in your test environments? No, no one. Okay, so yeah, this is something that y'all might want to look at because it might help with some of the cost issues associated with test data. Now, here comes more. Thank you. Here comes more good news. That's sarcasm, by the way. It's not good news. It's bad news. This graph is not your friend. This graph is definitely not happy news. That is a logarithmic scale, as I can talk. So, you know, every line there is an order of magnitude jump. The blue line is capacity increase over time since 1979. And the red line is throughput. See that? Oh, no. Oh, 10, 100, 1,000. Oof. It's 1,000-fold change there with respect to the relationship between capacity and throughput. So, yeah, Moore's Law has done a great job for us in a lot of ways. Moore's Law has done a hell of a job for us in terms of increasing storage capacity, right? But the data has to get from where it is to where it's going to be of use, yeah? And, you know, when you're copying the data, when you're anonymizing the data, when you're trying to manage all this data that's dealing with production size, this is not your friend. See what I mean? You might say, well, right now I'm only dealing with 5 gigabytes. Yeah, well, give it time, right? Give it time, because the trend is just get as much data as you can, right? grab all sorts of data and store it. What are we going to do with it? I don't know. We'll use it someday. Yeah, but you got to test with it, right? So you have to have a strategy for that. Here's something else that you might need to think about. Are you dealing with a specialized application of some sort or another? Like, for example, SAP. A lot of our clients use SAP. Other similar types of applications. Now, for the more common enterprise applications, there are commercial anonymization tools to help with the anonymization problem. But if you're dealing with something that's got a much smaller customer base, either because it's brand new or because it's really old and it's being phased out, that's going to be a problem, because there's really not going to be financial incentive for the creation of the tool. Even if there is a tool now, if the application you're using is being phased out, that tool is, do you really want to count on it? And there's no real incentive for open source, right? Same problem with the NoSQL database stuff is that, what are all the tools focused on? A lot of these data generation, and anonymization tools are sort of based on the assumption that you're doing something relational. I can generate tables and bulk load them into the relational database, right? Well, maybe that's not going to work for you for your big unstructured globs of click data that you've gathered up. Now, ideally, people would think about this kind of stuff when they were designing systems and when they were acquiring systems. Like, you would hope that your enterprise folks wouldn't go out and decide, hey, we're going to get this application from this vendor that refuses to share any sort of metadata about the underlying database. You'd hope that they wouldn't do that, because if you don't know how the data is set up in the underlying database, lots of luck anonymizing it, lots of luck copying it, lots of luck generating data, loading data, so forth, right? But, did people actually think about that? Maybe not. So this is something also to consider, is that there could be these sort of somewhat obscure apps that you have to deal with where, for very unfortunate reasons, there's just nothing out there to help you. So you resort to the compiler. In other words, you build your own. And that sucks. Okay, that's the last resort, right? Building your own data generation, data anonymization tools, that sort of thing, going out there and having to try to reverse engineer how a database is built. That's not good. Now, I have clients that just, they love that stuff. That's like the first thing that they want to do. Like, one of my clients is like, we're going to build our own test management system. And they're this huge company. If I said their name, you'd know them. And they have like 1,000 testers and probably 30 different test groups spread out all over the world. We're going to build our own test management system. It'll be fun. I know it won't be fun. It'll be an unmitigated disaster. I said, do the math on how many person centuries of work are represented by Quality Center, okay, now called ALM, right? Think about it. How many person centuries of development effort went into creating that? Now, you might say, well, we only need 10% of the features in that. Fine, take 10% of those person centuries. How much time do you want to invest in that? Okay? So last resort is building your own here. Okay? First resort would be going to the open source stuff, right? Second, commercial tools. Yeah. But, exhaust many, many, many options before you decide, oh, I'll just sit down and start writing code. Okay? Because that's going to be a problem. Now, So, assuming that you're not going to write your own, I hope I've successfully talked you out of trying that, you need to go get a tool. So, open source or commercial, doesn't matter. Open source tools are not free. They are free to download. That is not the same as free to have. If you're having any difficulty with this concept, I have 2 words for you. Free puppy. Okay? Free puppy. Free dog. Here, free dog. Okay? Is that dog free? Will that dog cost you nothing to have? No. The dog will tear up your apartment. The dog will pee in your apartment. The dog will eat your kid's dinner. Okay? Free tools are like free puppies. Right? They're useful, but they don't cost nothing to have. So, regardless of where the tool is and what the cost to buy it is, get your team together, know your requirements. And the worst possible requirement for a tool is, I used this at my last job and it was really cool. I hear that so many times. I'm just like, are you kidding me? Are you at your last job? You're at a different company. Different requirements. Stop, think, right? Or everybody's doing it. Everybody uses this tool. It's so great. Yeah, no, I hear it. I mean, it's incredible. Know your requirements. If you can't think of 50 requirements for your test data tool, I would guess either you're on slide 3, the simple one, and you're dealing with a very simple problem, or you just haven't thought about it long enough. Okay? Now, you might not be able to come up with those requirements all by yourself, but other people will have them. Talk to people. Risks and constraints. Know the risks and constraints. Okay? Don't go and put on your short lists of tools to look at tools that cost $1 million when you have a budget of $50,000. Because you just can't have it, right? I travel a lot. I fly all over the place. I really need a private jet. I really do. It would make my life so much easier. Guess what? I will never have a private jet. That's just a constraint of my life. Okay? So I got to figure out how to deal with that. Figure out what your options are. Look broadly. Okay? There are lots of options out there. Yes, in some cases there will be some limitations, but there's a lot out there. Select a tool and then pilot it. Don't make a final decision. Don't spend any real money, any big money, until you've done a pilot. Okay? Because you might have thought you figured everything out. But, I mean, I've had a lot of sad stories with clients that, a key element of the sad part is we skipped the pilot. We bought the tool and deployed it to the entire organization. And then, So don't try to shortcut this process, please. I mean, I so many of these horror stories that I hear just because somebody tried to skip a step. Okay, so I only have one person leave in the middle of the presentation, so I'm assuming that all of you actually are dealing with enterprise scale data. So I said at the beginning, that if you're dealing with a simple thing, you can get up and leave. That's okay. So simple apps, small scale stuff, yeah, that's easy. But when you get into the large stuff, there's all sorts of challenges. And I just focused on test data here. There's a whole sort of parallel presentation that I could do about environments, and they're kind of related. But just focusing on data, we saw challenges that are like, where are we going to get it? How do we deal with personal identifying information? What are our tools challenges? Size, costs, making sure that things are still useful from a testing point of view. So, figure this stuff out before you get yourself into a situation that's hard to extract yourself from, right? It's like that rule about don't go into a room that you don't know how to get out of. Yeah, this is one of those situations, except that it's really, really easy. A lot of people do it. They get into situations, and then later they realize, oh, no. And there aren't any big flashing red lights. I mean, maybe you have these in your life, but I don't have these big flashing red lights in my life that go off saying, you're about to make a horrible mistake. You'd have that? No, I mean, I don't. I mean, what happens is 6 months later you go, oh, crap, I made a horrible mistake. Right? So the whole point of this presentation was, I'm trying to be that flashing red light. Don't make a horrible mistake with the test data because it'll be really painful later. Okay? So I hope that I've given you some ideas on how to go off and go, okay, these are the problems that I have, and this is the how to approach it from a planning point of view.